The University of Delaware leads a national consortium called NIIMBL, the National Institute for Innovation and Manufacturing Biopharmaceuticals. So universities are important stakeholders within the NIIMBL ecosystem. They're often the heart of early stage technology development and innovation, and they also play a critical role in workforce training, ensuring we have the biopharmaceutical manufacturing workforce that we need for the future. When the pandemic was in its more intense phase, the US government asked NIIMBL and the University of Delaware what it could do to help prepare for, respond to, and prevent coronavirus outbreaks. One of the ideas that we had was to create a plasmid DNA manufacturing capability that was transportable. IPS was a great partner for us. They're active inside NIIMBL. They are a world leader in the design and construction of these facilities. And with funding to the Department of Commerce and the National Institute of Standards and Technology, or NIST, we built this capacity and capability to see if we could actually do it.
When IPS has their relationship with GCON, the ICON partnership, we thought it would be great. It wasn't like we had to go out and find a clean room wall manufacturer or anything like that. They already had a pod design that they can build off of.
One of the other advantages of the modular design was that it went into an existing facility that needed renovation and retrofitting. So that work could be going on while the actual process part of the facility was being built in Texas.
Trying to get a space that was able to take it from a totally unconditioned warehouse up to a grade C space is just not something that we do too often. We dealt with a 60-year-old substation, electrical substation that we had to kind of try to reuse. So we had to figure out a way to provide power to the facility. We didn't have to make any architectural modifications in order to build this clean room. So we were able to actually just bring it in and push it all together.
Just about everything in this facility that touches the product is disposable, one-time use, and therefore we don't need a lot of utilities. We don't need clean water systems, we don't need clean steam systems, and it lets us keep our focus in the process facility. Also, that equipment is sized right so that we can fit it in the facility, and if we want to scale up, there's equipment that we could fit in here to do that. So it leaves us a lot of flexibility.
NIIMBL's mission is really around testing, maturing, demonstrating, and de-risking technologies necessary for biopharmaceutical manufacturing innovation. I think now that we've established that we can actually build the capacity, it's time to test out the limits of that capacity as we move into more of an operational phase. How well does this perform? How far can we push the limits? Can we use it for workforce training? Can we use it for innovation? We can now imagine in the United States having more of this capacity created around the country that could be surged to wherever it's needed.